Table B 310.11 is not applicable for derating residential conductors. Table B 310.11 addresses adjustment factors for raceways containing more than 3 current carrying conductors, but it's not designed for residential wiring applications. While residential wiring inherently benefits from load diversity, the adjustment factors outlined in Table B 310.11 are specifically not applicable in residential contexts. Therefore, derating the conductors based on this table is not appropriate. Load diversity in residential electrical systems refers to the phenomenon where not all electrical loads are operating at their maximum capacity simultaneously. This is due to varying usage patterns of appliances, lighting, and other electrical devices within a home. Because of load diversity, the overall demand on the electrical system is typically less than the sum of the individual loads if they were all operating at their peak. The NEC provides specific rules and guidelines for residential wiring to account for this load diversity. However, Table B 310.11 is not part of those residential specific guidelines. To elaborate, let's consider the original scenario of a 200 amp service upgrade in a single phase, 120/240 volt system with 75 degrees Celsius lugs and a 24 circuit power panel. The electrician installed 24 current carrying conductors in a 2-inch raceway, with 12 of those conductors being #14 THWN wires. In this situation, the NEC provides specific guidelines for ampacity adjustments and corrections, but Table B 310.11 is not one of them when dealing with residential wiring. Instead, you would refer to the ampacity tables within the NEC that are specific to the type of conductor, its temperature rating, and the ambient temperature in which it's installed. These tables, such as those found in NEC Table 310.15b16, provide the allowable ampacities of conductors based on their insulation type and temperature rating. Additionally, you must consider any applicable ambient temperature correction factors as specified in NEC Table 310.15 bone and termination temperature limitations as per NEC 110.14c. To illustrate further, let's delve into the process of determining the appropriate conductor size for a residential circuit. Firstly, you need to calculate the load that the circuit will be serving. This involves determining the total amperage of all the devices and appliances that will be connected to the circuit. Secondly, you must apply any applicable demand factors as permitted by the NEC. Demand factors allow you to reduce the calculated load based on the assumption that not all devices will be operating simultaneously. The specific demand factors will vary depending on the type of load and the number of devices connected to the circuit. Thirdly, you need to select a conductor size that has an ampacity equal to or greater than the calculated load after applying demand factors. You should consult NEC Table 310.15b16 to determine the ampacity of different conductor sizes based on their insulation type and temperature rating. Fourthly, you must consider the termination temperature limitations of the equipment to which the conductors will be connected. NEC 110.14c specifies that conductors must be selected and installed so that their temperature rating is not exceeded at the terminals. This may require you to use a larger conductor size than would otherwise be necessary based solely on the calculated load. Fifthly, you should take into account any applicable ambient temperature correction factors. If the conductors will be installed in an area with an ambient temperature higher than 30 degrees Celsius (86 degrees Fahrenheit), you must apply a correction factor to reduce the allowable ampacity of the conductors. NEC Table 310.15 bone provides the correction factors for different insulation types and ambient temperatures. Sixthly, you need to ensure that the conductors are properly protected against overcurrent. This involves selecting an overcurrent protection device, such as a circuit breaker or fuse, that has a rating equal to or less than the ampacity of the conductors. The overcurrent protection device must be installed in accordance with NEC requirements. It is essential to consult the latest edition of the NEC for the most up-to-date requirements and guidelines for residential wiring. The NEC is a comprehensive document that provides detailed information on all aspects of electrical installations, including conductor sizing, overcurrent protection, grounding, and bonding. Adhering to the NEC ensures the safety and reliability of electrical systems in residential buildings. Additionally, it's crucial to consider the specific requirements of the local electrical code, which may have additional or more stringent requirements than the NEC. Local electrical codes are typically adopted and enforced by local municipalities or jurisdictions. To summarize, the derating rules specified in Table B 310.11 are not applicable to residential wiring installations. Instead, use the ampacity tables and correction factors in NEC Article 310 and ensure compliance with NEC 110.14c for proper conductor sizing and termination. Understanding and applying these rules correctly is essential for ensuring safe and compliant electrical installations in residential buildings. Always consult the latest edition of the NEC and local electrical codes for the most accurate and up-to-date information. Keep in mind that this information is for educational purposes and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or installations. They will have the knowledge and expertise to ensure that the work is done safely and in accordance with all applicable codes and regulations. Remember, electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself and others from electrical shock and fire hazards. Always turn off the power to the circuit before working on any electrical components, and use appropriate safety equipment, such as insulated tools and gloves. If you are not comfortable working with electricity, it is best to leave it to a qualified electrician. They will be able to handle the work safely and efficiently, and they can also help you identify any potential problems or hazards. By following these guidelines, you can ensure that your residential electrical system is safe, reliable, and compliant with all applicable codes and regulations. This will help to protect your home and family from electrical hazards, and it will also ensure that your electrical system operates efficiently and effectively. In addition to the information provided above, it is also important to consider the following factors when designing and installing residential electrical systems. Firstly, the type of occupancy of the building. The NEC has different requirements for different types of occupancies, such as dwelling units, apartments, and hotels. Secondly, the size of the building. The size of the building will affect the overall electrical load and the number of circuits required. Thirdly, the types of appliances and equipment that will be used in the building. The types of appliances and equipment will determine the specific electrical requirements for each circuit. Fourthly, the location of the building. The location of the building will affect the ambient temperature and the potential for exposure to moisture and other environmental factors. Fifthly, the local electrical code. The local electrical code may have additional or more stringent requirements than the NEC. By considering all of these factors, you can design and install a residential electrical system that is safe, reliable, and compliant with all applicable codes and regulations. This will help to protect your home and family from electrical hazards, and it will also ensure that your electrical system operates efficiently and effectively.